Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Heather. You're watching Learn and Teach by Sir Ayaz. So I'm continuing my O-level past papers session, and this time I've selected IGCSE Chemistry 0620, and the paper is 43. It's of May-June 2024. You know the time, 1 hour, 50 minutes. It's paper 4, theory, extended version. You have to answer all the questions on all the answers on this question paper. You can use calculator. The total mark for this paper is 80. Periodic table is printed in the question paper. So let's start the paper. Here's question number 1. Name the process used to A, produce ammonia gas. This is something which you have to learn by heart. It's Haber process. So you write Haber here. Haber is a process. Haber process. B, produce lead from molten lead to bromide. We have electrolysis. Electrolysis will produce lead from lead to bromide because lead is among more reactive metals. So we'll go for method of electrolytic reduction. So we'll write electrolysis. C, separate an insoluble solid from a mixture of an insoluble solid and a solution. It's very common. You all know that's filtration. Filtration is a process used to obtain insoluble solid from a solution. D, produce ethanol from ethene. The process is addition. It's a type of addition reaction. So you will either write hydration or catalytic addition. Hydration means addition of steam or water to ethene here. Hydration of ethene. Hydration or catalytic addition. Next part. E, identify the components of a mixture of soluble colored substances. Now, the process used to identify the components that are present in the soluble color substances is chromatography. This process helps to separate the components of colored substances. F, separate a mixture of several liquids with different boiling points. It's actually miscible liquids. They all known as miscible liquids. Miscible liquids are those liquids which mix into each other, and the difference is in their boiling points. The process is known as fractional distillation. Part G, determine the volume of an acid required to neutralize a given volume of an alkali. The process is known as titration. This method involves to find the concentration or volume of acid or alkali from the given set of informations. So we have titration. Moving to next question, which is question number 2. Complete table 2.1. We have atom or ion, number of protons, number of electrons, and number of neutrons. For Cu, the proton number is given, it's 29, and the nucleon number is 63. Number of protons is 29. What about the number of electrons? It should be equal to the number of protons because we don't see any charge on Cu. So you simply write 29 here. What about number of neutrons? In order to find the number of neutrons, subtract the protons from nucleon number. So you'll write 63 minus 29. Minus 29. The answer is 64. Sorry, 34. So the number of neutrons is 34. What about Cl minus? Now this time you see there's a charge on Cl. It's negatively charged ion, also known as anion. Proton number is 17, nucleon number is 37. So for the number of protons, I will write 17. What about number of electrons? You see the charge, it's minus, which means you have to add 1 electron to this number. 17 plus 1. And we will get 18. So 18 will be the number of electrons in this Cl negative. Number of protons, number of neutrons are given, which is 20. Now you have to write the symbol for the atom or ion. From the given set of information, we have number of protons 30. So I'm going to do a periodic table to identify that element. That element is zinc. You see the number? So the symbol must be Zn. And number of protons is 30. So I will write 30 the bottom of baseline. Number of, not baseline, base. Number of electrons. They have given 28 as the number of electrons, which means it has lost 2 electrons. So you have to write charge on Zn, which will be +2. What about nucleon number? Add number of neutrons and number of protons. So 30 plus 34 becomes 64. So I will write 64. This will be the final answer. Moving to next question, which is question number 3. Question number 3, this question is about elements and compounds. A. Some properties of graphite, oxygen, and carbon monoxide are shown in table 3.1. Table 3.1 is given here. You see you have graphite, oxygen, carbon monoxide, melting point, boiling point, and conduction of electricity when solid state. The information is provided to us. In part 1, explain why graphite conducts electricity when solid. Now, graphite, they contains mobile or delocalized electrons. You can write mobile or delocalized electrons. Moving to next part, which is part 2, complete the dot and cross diagram in figure 3.1 of a molecule of oxygen. Show outer shell electrons only. Where is oxygen? Here is oxygen in the periodic table. It's in group 6, which means it needs 2 electrons to complete its valence shell. So both of these oxygen atoms needing 2 electrons to complete the valence shell. So they will share 2 of their valence electron. So for one oxygen atom, I'm using dot. And for the other oxygen atom, I will use cross. So for the right hand side, I'm using dot 1, dot 2, 2, 3, 4, 5, 6. Now the left hand side, I'm using cross. 1, 2, 3, 4, 5, 6. This will be the final dot and cross diagram for this oxygen molecule. Part 3. Reduce the physical state of carbon monoxide at -195 degrees centigrade. Use the data in table 3.1 to explain your answer. So first of all, I need to write the physical state of this carbon monoxide at -195. Here's carbon monoxide. So you see here, -199 is the melting point, boiling point is 191. -191 is definitely higher than this melting point. So -195 5 is between these two. So physical state must be liquid. For the explanation, refer melting and boiling points. Just write down the melting point and boiling points in order to complete your answer. Moving to next part, which is part 4, explain in terms of structure and bonding why graphite has a much higher melting point than carbon monoxide. Now graphite is an allotrope of carbon. It's a giant structure. So you will start with the giant structure. For carbon, for graphite, if you want to write for graphite, you will write giant covalent structure, or graphite as giant structure. Giant structure with many or strong covalent bonds. With many or strong covalent bonds. You can even mention strong attraction or strong attraction. You can even write the reverse argument or reverse argument for carbon monoxide. For carbon monoxide, which is that it has simple molecule or structure. Simple molecule or structure. Refer to the forces present, which is weak, with weak intermolecular forces. Weak intermolecular forces. Part B, potassium reacts with chlorine to form potassium chloride. Write a symbol equation for this reaction. Now, symbol of potassium is K. K is potassium. Symbol is K. See here. It's reacting with chlorine. You know that chlorine, group 7 element, they all exist in the diatomic state. So I will write K plus Cl2. Don't write Cl. You have to write Cl2 because these are it's a halogen, and halogens exist in the diatomic state. So the product for this reaction, what will be the product? We will get potassium chloride. Now predicting their formula. Formula for potassium, valency for potassium is +1, it's in group 1. For chlorine, it's -1, it's in group 7. So we have the valency for potassium as well as chlorine. Ignore their charges. Swap these numbers. So you'll get KCl. So final formula must be KCl. Now balance it. We have 2 on Cl on the left hand side. So I'm going to place 2 before KCl. Now we need to balance K also. So place 2 also. This reaction is balanced now. Part C. A dilute aqueous solution of potassium chloride undergoes electrolysis. So we have dilute aqueous solution of potassium chloride. It's undergoing electrolysis. Oxygen is produced at the anode. 1. State what is meant by the term electrolysis. Electrolysis is made up of 2 terms, electricity and lysis. Lysis means breakdown. This means breakdown. And this is current. So what you're going to write? Break down through passage of electric current. Break down through passage of electric current of ionic substance. Remember, it's breaking down ionic substance of ionic substance. Now, this statement is not enough. You have to mention the states of ionic substance in which you are going to breaking it down. So it's either in molten state or aqueous solution. In molten or aqueous solution. Number 2, write an ionic half equation for the production of oxygen at the anode. Now you have to write the ionic equation for the production of oxygen at the anode. We will start with the hydroxide ion. We have OH negative ion, aqueous. The products obtained is oxygen. It's not only oxygen, water is also produced. Now let's balance the equation. It's balanced now. I'm writing the state symbols. Oxygen is a gas, water in the liquid state. Now this is fine. Next question, number 4. Dinitrogen tetroxide N2O4 decomposes into nitrogen dioxide NO2. The reaction is reversible. Is the reaction N2O4G, colored as gas, reversible sign, 2NO2G, brown gas. Figure 4.1 shows a gas syringe containing a mixture of dinitrogen tetroxide and nitrogen dioxide. The gas syringe is sealed. The mixture reaches equilibrium and the color of the mixture of gases is a pale brown. So it's a diagram. We have end sealed and we have plunger on the right hand side. And in this syringe, there is a mixture of dinitrogen tetroxide and nitrogen dioxide. A, describe a reversible reaction at equilibrium in terms of the rate of forward reaction and the rate of the reaction. A reverse reaction. Remember, it becomes equal when a reversible reaction reaches to the equilibrium state. So you write becomes equal. Concentration of reactants or products, they remain constant or no longer changing. Going to next part. B, the pressure of the mixture is increased. All other conditions stay the same. The mixture immediately turns darker brown before the position of equilibrium changes. Explain in terms of particles why the mixture immediately turns darker brown. Now pressure is increased. If you increase the pressure, what will happen? Increasing pressure will shift the equilibrium to left hand side. Fine. So it means that it will turn to less brown or paler brown. But what they are saying mixture immediately turns darker brown. Now it's turning darker brown immediately before the position of equilibrium changes. So they are saying before the position of equilibrium changes, because after the equilibrium, it will definitely turn into paler brown. But why it's turning darker brown? So what's happening initially, there will be higher number of particles of NO2 per unit volume. You see the color of NO2 is brown, brown gas, it's a brown gas. So what you will write? You will write higher number of particles. Higher number of particles per unit volume of NO2 per unit volume, or more particles in lesser volume of gases. C. The temperature of the mixture is increased, all other conditions stay the same. The mixture turns darker brown. State what can be deduced about the forward reaction from this information. If you're increasing the temperature, so what's happening? The mixture is turning darker brown, which means it's shifting to the right hand side, that is the product side. So forward direction must be exothermic. So delta H for the forward direction must be minus. Backward direction must be endothermic, which means delta H must be positive. So what can be deduced about the forward reaction? You can simply write forward direction is endothermic. Sorry, it's wrong. It must be endothermic in the forward direction. So you will write endothermic. Moving to next part, sulfur is converted into sulfuric acid H2SO4 by a series of reactions. Sulfur dioxide SO2 and oxygen O2 reacts to form sulfur trioxide SO3. The reversible reaction reaches equilibrium. Here's the reaction equation: 2SO2G plus O2G, reversible sign, 2SO3G. 1. Complete table 4.1 using only the words increases, decreases, or no change. So what will be the effect of adding a catalyst on the rate of forward reaction? So it will definitely increase. So you will write increases. What about the effect on the equilibrium yield of SO3? Remember, catalyst only increases the rate of reaction. It doesn't have any effect on the yield of the products obtained. So you'll write no change here. Increasing the pressure. So the effect of increasing the pressure, it will definitely increases the rate of forward reaction. So I will write increases. What about the equilibrium yield of SO3? So if you increase the pressure, it will shift to the right hand side. Equilibrium will shift to right hand side. Increase pressure. So why? Because you have less number of moles on the right hand side and high number of moles on the reactant side. In the reactant side, you have 2 plus 1 is equal to 3, and you have 2 moles on the product side. So it will definitely increases the yield of SO3. Number 2, reduce the oxidation number of sulfur in S. S is carrying no charge, so I will write 0. What about SO3? S is below oxygen in group 6. So oxygen must be more electronegative than S. So the charge, that is oxidation number of oxygen, is -2. Let's work out the oxidation number of sulfur. X. Yes, there are 3 atoms of oxygen, so I will add 3. Oxidation number on oxygen is -2. Overall, we don't see any charge, so I will write 0 here. So X minus 6 is equal to 0, or X finally becomes +6. So I will write +6 here. 5A. Barium sulfate BaSO4 is an insoluble salt and is made by precipitation. 1. Name 2 aqueous solutions that produce a precipitate of barium sulfate when they are mixed. Now we need 2 aqueous solutions to get a precipitate of barium sulfate. So you must have soluble salt of barium. You can either take barium nitrate or chloride. Either barium nitrate or barium chloride. For number 2, soluble salt, soluble sulfate. So you can take sulfate of either sodium, soluble, potassium, or even magnesium. You can take any sulfate of these. Number 2, describe how to produce a pure sample of barium sulfate from the mixture of aqueous solutions in A1. Now it's insoluble. It's obtaining. We are obtaining it as precipitate. So which means that it's an insoluble salt. So you have to filter. Then you have to wash the residue with distilled water. Wash the residue with distilled water. The last but not least, and dry it. Okay, dry it in air. Number 3, write an ionic equation for the precipitation reaction which produces barium sulfate. Include state symbols. Now we need to make the ionic equation for barium sulfate. The formula for barium sulfate, it's provided. So the product must be BaSO4. And it must be in the solid state. So I will write the solid state. What about the reactant side? You must have the barium ion and sulfate ion combining. Barium belongs to group 2. Here is barium. Group 2, the valency of group 2 is +2. And sulfate ion carries -2. So Ba +2 plus sulfate SO4 -2. Now state symbols must be aqueous. On the left hand side, both are coming from the soluble salts. So I have to write aqueous. B, soluble salts are made from dilute acids. Name the dilute acid and one other substance that react together to make copper 2 sulfate. So you need to make copper 2 sulfates, which means there must be sulfate ion. Sulfate ion is coming from the sulfuric acid, so the acid must be sulfuric acid. For copper, you can take oxide, hydroxide, even carbonate of copper. Copper 2 oxide or hydroxide or even carbonate. You can take any one of these. Number C, nitrates decompose when they are heated. When hydrated copper 2 nitrate is heated, oxygen gas is produced. 1. Describe a test for oxygen. Now you have to describe a test for oxygen. The test must be glowing, splint, or matchstick. And this will be relighted. Relighted. So you relight, because oxygen is a gas that helps in burning. Part 2, complete the equation for the decomposition of hydrated copper 2 nitrate. We have 2CuNO3 whole twice, dot 3H2O gives blank CuO plus blank NO2 plus O2 plus blank H2O. So we don't need to balance oxygen. We need to balance CuO and O2 H2O. Now, looking at the reactant side, we can balance CuO. I will write 2 before CuO. Now, copper is balanced. What about nitrogen? 2 multiplied by 2. It must be 4. Nitrogen. Cu is 2 here. Nitrogen. It's 4 on the reactant side. What about oxygen? 2 3s are 6, 6 2s are 12. And 3 2s are 6. 6 plus 12 is 18. So here must be 18. So NO2 must be 4. I am writing 4 before NO2. Now I need to balance water. Let's see hydrogen on the left hand side. That's reactant side. 3 2s are 6. 6 2s are 12. So we have 12 hydrogen. So I have to write 6 before H2O. Now let's see either this is balanced equation or not. Copper, is it balanced? Yes, it's balanced. 2 2. Nitrogen, 2 2s are 4. 4 on the product side. It's also balanced. What about oxygen? 2 from CuO. 4 2s are 8 plus 8. And 2 from O2 plus 6 from H2O. Adding these, 8 plus 2 is 10, 10 plus 2 is 12, 12 plus 6, 18. It's also balanced. Hydrogen is also balanced. This equation is balanced. Part D, hydrated zinc sulfate gives off water when it is heated. ZnSO4 dot X-H2O-S gives ZnSO4S plus XH2OG. A student does an experiment to determine the value of X in ZnSO4 dot XH2O. Step 1, student weighs a sample of hydrated zinc sulfate. Step 2, the student heats a sample of hydrated zinc sulfate. Step 3, the student weighs the solid after heating. Step 4, the student repeats step 2 and step 3 until the mass of solid after heating is constant. Number 1, state why the student does step 4. Now, why the student is repeating step 4? It's ensuring that all the water is removed, to ensure that all water is removed or given off. Number 2, in an experiment, 0.574 gram of ZnSO4 dot XH2O is heated until the mass is constant. The mass of ZnSO4 that remains is 0.322 grams. MR of ZnSO4 and H2O, it's provided. Determine the value of X using the following steps. Number 1, calculate the number of moles of ZnSO4 remaining. You know that the formula, mass divided by MR. Mass divided by MR. Mass is provided which is 0.32. MR is given, which is 161. So 0.002. 0.002. This is the mole of ZnSO4 remaining. Calculate the mass of H2O given off. In order to get the mass of H2O, need to subtract the mass of ZnSO4 obtained from the mass of the initial mass. So I will write 0.574 minus 0.322. So 0.574 minus 0.322. We will get 0.252. 0.252 grams. Now calculate the number of moles of H2O given off. You know, the same way, what you will do, you will divide the mass obtained by the MR of H2O. So 0.252 divided by 18. So you will get 0.014 mole. Determine the value of X. Now we have the moles of ZnSO4 and the moles of water. So you write ZnSO4, H2O, ZnSO4 0.002. Reacts 0.014 mole of H2O. This is also mole. Therefore, 1 mole react with X mole of H2O. Do the cross. So you will get X is equal to 0.014 divided by 0.002. So the answer, it's 7. So 7 must be the final answer for this one. Moving to next question. It's question number 6. This question is about iron. A. Figure 6.1 shows a blast furnace used to extract iron from its ore. Here's blast furnace. Figure 6.1. You have waste gases coming from the top. You have raw materials, coke, iron ore, limestone. And bottom you are getting molten iron. Number 1, name the main ore of iron used in the blast furnace. It's hematite. So you write hematite. Number 2, name the substance that enters the blast furnace at A. So you must be adding air from here. Part 3, name the reducing agent in the extraction of iron in the blast furnace. They are asking about the reducing agent. Main reducing agent is carbon monoxide. It reduces the iron oxide into iron. 4, explain why limestone is added to the blast furnace. Give details of chemical reactions that are involved. So limestone, it's used to remove the impurities. So it initially decomposes into calcium oxide and carbon dioxide. So I will write limestone thermally decomposes into calcium oxide and carbon dioxide. Now this calcium oxide reacts with silicon 4 oxide producing slag. They are asking you to write the details of chemical reaction, not the chemical reaction. So you'll write the details. So I write calcium oxide reacts with silicon phosphor oxide. This is the main impurity in the iron ore. Which get converted into slag. Slag is calcium silicate. Part B. The list shows the properties of some elements: act as catalysts, have low densities, have low melting points, form acidic or basic oxides, form colored compounds, form positive or negative ions. Iron is a transition metal. Sodium is a group 1 metal. State which property from the list. Number 1 is true for sodium but not iron. Where is sodium? Here is sodium, it's in group 1. Where is iron? Iron is here. It's in the transition metal. Among transition metals, we have so true for sodium but not iron. So for sodium, it has low density. You can either write low density or low melting point. And you can also refer to the compound form, which is not colored for sodium. So I'm writing either low densities or low melting points. So sodium does not form colored compound. So these 2 points are true. Don't write or, they are saying true for sodium. They are not saying any one. So you have to choose, you have to write both the properties. Number 2 is true for iron but not sodium. All that applies to iron. It acts as catalyst, yes. It forms colored compounds, yes. These are the 2 properties that are true. Act as catalyst and form colored compounds. Part 3 is true for both sodium and iron. No, this one is true for both these sodium and iron. They both form basic oxides and form positive ions. Form basic oxides and positive ions. Number 4 is not true for sodium and not true for iron. So which property? They do not form negative ion as well as acidic oxides. Form acidic oxides and negative ions. Moving to part C. Steel consists mainly of iron. Iron rust when it reacts with water and oxygen. Figure 6.2 shows magnesium blocks attached to the bottom of a steel boat. The magnesium does not completely cover the steel. The magnesium blocks provide sacrificial protection for the steel. So here's a diagram. We have steel boat. There are magnesium blocks attached at the bottom of this, and there's a water containing dissolved oxygen. Number 1, explain why, in terms of electrons, why magnesium is used for sacrificial protection. So magnesium, it's above iron, so it's more reactive than iron. So it will lose electron more readily. Magnesium loses electrons more readily than iron. Because Mg, more reactive than iron. You can even write it lose electron more readily or in preference or instead of iron. Number two, name a metal that cannot provide sacrificial protection for steel. So you can write any metal below iron. Any metal below Fe. So you can have silver, copper, or gold. These do not provide sacrificial protection because. Question number 7. Many organic compounds contain carbon and hydrogen only. A, part 1. An organic compound A has the following composition by mass. C, 83.33%, H, 16.67%. Calculate the empirical formula of compound A. So here's the composition which is provided to you. Carbon is 83.33%. I'm writing 83.33. What about hydrogen? It's 16.67. Now AR of carbon, here is carbon, it's 12. Hydrogen is 1. So for carbon, I'm writing 12. For hydrogen, I'm writing 1. So you should divide 83.33 by 12. What you will get? You will get 6.94. 6.94. For hydrogen, you will get 16.67. 6.94 is the smallest value here. So I'm dividing both of these by 6.94. For carbon, I will get 1. For hydrogen, I will get 2.40. 2.40. Now we need to get the answer in whole number. We have to multiply it by a number. So if you multiply 2.4 by 2, what you will get? We'll get 4.8, which is not acceptable. Let's multiply it by 3. We are getting 7.2. It's also not acceptable. What about 4? 9.6, not acceptable. 12. So it means we have to multiply it by 5. So you will get empirical formula C5H12 here. Move to next part. Part 2, compound B has empirical formula C2H5 and a relative molecular mass of 58. Determine the molecular formula of compound B. Now we need to find the molecular formula of compound B. For this, we need to find the value of N. N is the number. In order to get the N, we need to divide molecular mass by empirical mass. Empirical mass is empirical formula is provided. So empirical formula mass C2H5. We have 2 atoms of carbon, so we'll multiply 2 by 12. We have 5 atoms of hydrogen, 5 multiplied by 1. And adding up these values, 24 plus 5, you'll get 29. So we need to divide 58 by 29. What you will get? You will get 2 here. So we'll multiply 2 by C2H5. 2 C2H5. And answer will be C4H10. Part B. Figure 7.1 shows a section of a polymer formed from an alkene. 1. Identify the functional group in alkenes that reacts with when alkene form polymers. It's carbon-carbon double bond. So you write C double bond C. It's the functional group in alkene which reacts to form polymer. Number 2, a section of a polymer is shown in figure 7.1. Draw the displaced formula of the monomer that forms this polymer. I need to pick the repeating unit here. This will be the repeating unit. So I'm drawing the repeating unit here. C2H5, here bond H. Simply place double bond between these two carbon atoms. So this will become monomer of this. Name the monomer used to form this polymer. Now, what will be the name of this monomer? Here we have carbon-carbon double bond, and there are 4 carbon atoms, and the carbon-carbon double bond is on the carbon number 1. You have to start counting from this 1, 2, 3, 4. So it must be but. So you will write but 1-ene. But 1-ene. So this will be the name of this monomer. C. Alkenes are produced by cracking alkanes. When C12H26 is cracked, the products are ethene and an alkane, which form in a 2-to-1 mole ratio. Write a symbol equation for this reaction. So formula for ethene is C2H4, and they are saying it's in the ratio of 2:1. 2:1 with the other product obtained in this reaction, which is alkane. So I will write 2 before C2H4. So 2 multiplied by 2, 4. So there will be 4 carbon for this alkene. So subtract 4 from 12. 4 from 12. 12 minus 4 will get 8. So the alkane must be of the n value of n as 8. You know the general formula of alkane, CnH2n plus 2. So C8 means 8 multiplied by 2, 16. 16 plus 2 is 18. So C8H18, 18 must be the alkane obtained in this cracking reaction. D1, state the general formula for alcohols. General formula for alcohols, it's CnH2n plus 1 OH. CnH2n plus 1 OH. Part 2. Draw the displayed formula of one alcohol with the molecular formula C3H8O. Name the alcohol you have drawn. C3H8O, it must be propanol. Now, propanol, you must have 1 OH in this propanol. So you can either draw this by placing OH on carbon number 1. I am placing OH here. Or you will place a OH on carbon number 2, O bond H. Showing other H here. So if your answer is 1, the first one, let's call it A, and let's call it B. If your answer is A, alcohol A, so you'll write propane 1-ol. Propane dash 1-ol. The name is according to the functional group, which is OH in this, but you have displayed formula of alcohol B, then it must be propane 2-ol. As you can see, the OH is on carbon number 2. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.